All right, so how's everybody holding up? Do you still have some energy? Do you have some energy? Come on, I'm standing here in front of you. Come on, guys. Much better, kinda, thank you. All right, so we did a lot of talks about stuff that's broken, stuff that you need to think about. And I really want to thank Sebastian and Philippe for the talks about, what's being broken, what you think about, because I think that's an excellent starting point for this conversation. Because you'll realize the moment that you have to think of all these things, and he just gave an overview, man, there's way more. It's just only about APIs. You have to do something about that. And you have to do more about it the moment you start creating more deployments. The moment you start creating more value, there's more you need to protect, right? So I'll talk a little bit about myself in a moment. I first want to know a little bit about you guys. Who of you are developers? Can I see some hands? All right. Who of you is playing security? Who of you is managerial? Oh, there are actually more than one. Awesome. That hardly happens actually during my talks. I don't know why. Well, I kind of do. Anyway, if you talk about deployments, how many of you deploy at least once per year? If anybody didn't raise his hand, you should start considering what you're doing. Who of you is deploying once a month? Who of you is deploying once per 2 weeks? Who of you is able to keep that up as a pen tester? None, right? Cool. So, security automation, welcome. I hope with this I got you getting a little bit refreshed. And if not, let me know by yawning loudly so I can help you to go through the last talk. A little bit about me, that's me. I'm Jeroen Willemsen. I'm a security architect. I come from full stack development. That includes all the jazz within kernel stuff. And I have a knack for mobile security. Unfortunately, securing something on a mobile device doesn't make sense if you don't consider the rest of the infrastructure you're talking to. Ergo, here we go. So what are we going to talk about? Security automation. How do you automate security? And this is a little bit of a war story. So what we do, and I want to talk about that. It's just a simple four-parter. I hope I can give you an enjoyable ride for another 30 minutes. We'll start talking about the challenge. We'll start talking about the solution. And obviously, to be honest, there were bumps on the road. This is not something, well, it's actually easy, but you have to know that nothing comes for free. And then we'll have a little bit of a recap. Okay? Let's start with the challenge. So the challenge was to, if this works, sorry for technical difficulties. The challenge was to automate security in a week. I have to give a little bit of a context here. Basically, it was the end of 2016, and yeah, sure. Do you want to buy a bag? Proper sponsorship. All right, thank you. So we had a week. It was the end of 2016. So some of the proper tools you have right now weren't existing back then. And the customer asked us, can you do some security automation for us? It was the end of December, so that's often the week, with Christmas and New Year's Eve. So you have lesser time. Let's start running. Let's see what you can do there. The customer had, basically it started with some ancient infrastructure that did warehouse management, stuff like that, making sure you would move the right package to the right shelf and stuff like that. On top of that, they had a bunch of Amazon Web Services because, yeah, modernize, DevOps, in the cloud, let's go, which was beautiful. And that would then be the interface for the older mainframe-based systems to a bunch of Angular apps, Android apps, and an iOS app. Well, that looked all pretty cool, actually. It was a nice project. And they had an existing workflow. So you would first define your value in Jira, in terms of stories, yada, yada, yada. You would start creating some code to make that run. And once you start pushing that code, automatically the build pipeline will be kicked off. So they had a Jenkins pipeline. That was all pretty straightforward. It would do a pull and merge of your code. Based on that, it would start building your artifact. And it can be various things, right? It can either be preparing a Node application or preparing your Scala application with STPT or creating an actual Docker container given the materials that you just created. That would then be stored, Docker in the Docker registry, obviously, and your artifacts in Artifactory. And then obviously in parallel, you would have a bunch of unit tests running on there. And once the unit tests were completed, the artifact would be deployed to a development environment. And then you would do a bunch of end-to-end tests to reaffirm that the stuff is still working. And then you would have something ready for validation. So we were very lucky that this pipeline was already there, because you can't do anything if you have to first build that pipeline. Building a stable platform takes time. So we're very grateful that the platform team already created this. By the way, who of you already has such a thing, especially developers? Who of you is already using a build server and has a stable pipeline? Who of you doesn't? It's okay to just use scripts and runs on my machine, but I hope this presentation can help you to move away from that position. Because runs on my machine is kind of 90s, and well, let's move along. So the first thing that we needed to add there was, well, was dependency checker, obviously. And of course, retire for the JavaScript stuff. License checkers, because it was a commercial product. I wanted to make sure that we weren't violating any licenses, so you really want to make sure that you put all the right stuff in there. It's more of a legal thing, actually. The next thing was to check the containers with Claire. I'm just going to run because something's broken. To verify whether there were any vulnerabilities in there. Don't worry, I'll talk a little bit about Claire later. And obviously our favorite, dynamic analysis tools, OWASP ZAP, hey OWASP, and try burp, and a bunch of other things. Obviously that list becomes pretty long, lengthy. Thank you very much, sir. Let me see if that can fix this problem. Sorry for the... Yes, thank you very much. So what we didn't implement was static analysis tooling. Who of you knows what this is? Do I have any Scala love in the room? No? No Scala developers? Okay, a little bit of an easy one. Angular is well known probably. And Swift. The customer had a bunch of developers on board that really like to use the latest and greatest. And if you really love to use languages that evolve fast, such as Swift and Scala, your static analysis tools are in trouble because they don't understand what's going on. Especially with Scala, there's lots of transformations going on, especially if you use AppSec syntax trees on top of macros or the other way around. Then the bytecode represented is something completely different than what you would expect given your source files. So that doesn't fly. And we didn't want to waste our week on fiddling with that. We rather want to put something in there. So the solution, well, we got there kind of. This first and simple part, of course, is just to add the stuff to the build step that is easy, based on the quality tooling you already have. Because the thing that's really important is to provide feedback fast. The faster you are with your feedback, the easier you can break the build and start fixing this. So we started with the dependency and license checkers on top of the existing quality tooling. So for instance, with Scalari form, there's already some stuff from Scala, and then you can add the OWASP dependency check in there, which end up to something like this. So you could use Claire in parallel on the stored artifacts. And the moment that you would do your build, you would already do the quality tooling. But the moment you would start then to do end-to-end testing with ZAP and burp, you really need to proxy it, because back then there was no support for reading API definitions, for instance. You had to teach ZAP what was going on. So we proxied it to ZAP and burp. And as you can see, burp is a bit grayed out, and I have a good reason for that, unfortunately, but we'll talk about that a little bit later. And then you could, given what you just learned from the end-to-end test, do a quick scan. The funny thing about this is that all of a sudden, the quality of your end-to-end test and the coverage becomes important. Because if you didn't test it, especially with APIs, how can ZAP know it exists? How can ZAP test something it doesn't know about? Well, obviously, it can't test anything because, well, it doesn't know about it. Even if you would spider a JavaScript application, you would come to the same problem because the spider doesn't work that well with modern web application frameworks. So you would still be broken. So all of a sudden, testing became really important to us as a security team. And then we found out that there was still a lot of testing love necessary. And then, of course, the quick scan. After that, you could schedule it for a long scan. The reason that we did it like that is because you don't want to let developers wait for a long period of time. The moment your security controls in the pipeline become the delay, you're the frustrating party. And people will start turning it off. Because face it, it's about the developers that create value. That's what drives your customers. It's not us, the security people. We're offering a service. We're very long way along in line. We're not the firsts. We're the ones who try to protect something. But if you don't have value to protect, you have nothing. Therefore, make sure the developer can do its work. And I'll hammer that a couple of times because I think it's important that we as an industry understand that it's developers, developers. I'm not going to jump around like Balmer, don't worry. But I think it's important. All right? So the next thing, of course, was that we wanted to integrate it with something. So the moment that you would run Zap, it would have a bunch of results, and we want to feed it into ThreatFix. Back then, we chose ThreatFix because in the end of 2016, Defect Dojo and a bunch of other tools were in a pretty sorry state. That has been, well, an ongoing development and change. So I'm not saying that ThreatFix is a holy grail, nor that Zap is a holy grail, but those worked for us back then. And try to find your own, whatever you think is necessary. And based on that, when you would get a bunch of vulnerabilities reported by Zap into ThreatFix, you could then show or feedback the filtered results, because here the false positive filtering would happen, and give that back to Jenkins. And at the other end, as a security team, you could start talking about what you found, and together with a developer, and based on that, generate Jira tickets. And ThreatFix can take away a lot of the paperwork because, you know, automatic templating and stuff that's supported over there. So a lot of the details of the actual file will already be in there. One thing that I really would like to say again, it's about the developers. What I really don't like when I'm developing something is that somebody's shoveling up stuff in my backlog that I don't know about. Because that means all of a sudden I thought I knew what I was doing, and now all of a sudden there's new stuff I don't know, and the reporter is the security team. I'm sorry. That's not functionality, son, that's something else. So before you start adding stuff, go to your development team that causes the issue, probably. Start talking to them like, hey, I found something, there's something wrong. Look at this beautiful screen from ThreatFix or whatever. Is it okay if we create a ticket about it? And yes, I think it's pretty severe because of X, Y, and Z. Or, nah, it's just looking bad on our website. We can fix it later. It depends on, of course, the severity of things, and move along. The next thing, of course, as a solution was to run Claire on the created containers. Well, obviously, you could run Claire, but we didn't complete that. There was no regular run on the registry, and we didn't have any whitelists. By the way, who of you is familiar with Docker security in Claire? Okay, I'll give it a little bit of more love later on then, on a few other slides. And by now, we would have done this way more, in a way better way, and we'll talk about it a little bit later. And the most important thing about our solution was that we containerized. Our tools was mostly embedded in containers, because that means that you have less additional platform complexities. You don't have to maintain your own server, secure that stuff, etc. You can reuse what there's already out there. And you can make sure it's immutable. And you can run it everywhere. You can deploy this locally to first verify as a security team, hey, does this even work? Does this tool work the way we envisioned it? Do we get the results that we like? Or is it mumbo jumbo and do we need to do something else? And then when you run it in a deployed state, it should do the same thing. And it's easy to scale. It's not hard to jump around and have a bunch of containers deployed. It's way harder to, you know, spin up more virtual machines, run after everything, etc. And by the way, that should be a consideration for the platform team, not of us, the security dudes. All right, of course, you still need to manage the data. That's a challenge when you containerize, because just to make sure, who of you doesn't know Docker? Is everybody familiarized with mounting volumes in Docker and stuff like that and maintaining data? Okay, for those who didn't want to say, I'm sorry, I don't know. The problem with a Docker container is when you have the data inside and you didn't have any mounting points for submitting to something else, the moment the container dies, so does your data. So you still need to integrate this. We just use the SQL Server and later on, of course, Amazon RDS to store data in. But you still need to manage that and protect that properly. And obviously, the moment you introduce tools, the moment you introduce your own containers, you're introducing new assets to your playing field, which might contain vulnerabilities. So that's a bit of the thing you have to think about anything that you deploy. Because it might well be that you start opening up new threat scenarios that you didn't think about, because obviously we're mostly focusing on, let's develop a new tool, or buy a tool, or use a tool, implement it in our pipeline, and look, it found something. This tool is awesome. But what we might have forgotten is that whatever you put in your landscape might actually give way for new threat models. All right? So it was still not perfect. We still had to harden our assets. We just made sure we got the containers to run. We made it run in a week. We didn't make it pretty. You can't, obviously, in a week. So it's a good starting point. But still, just to give an example about the Claire scanner from Armin. So basically, we ran it, for instance, on our ThreatFix container, and it had over 10 layers. So that means that we did a lot of transformations. Just a little bit of an explanation. I think this is a proper time. So Docker containers are consisting of layers. Each transformation you do in your Docker file, for instance, will create a new layer. Those layers are stacked upon each other, and those layers form the container image. That image becomes an actual existing container the moment you start deploying it. All right? So the more layers you have, it means the more operations you did, and the more might have happened. What often happens actually is that people play around with this by doing a lot of operations in a single layer, like downloading a lot of different files in parallel, making sure all of that is getting executed. And the thing is, of course, that per layer you might add more binaries or more libraries, which means that your container grows fat. And not only that, binaries that you imported in your Docker container might contain vulnerabilities. It's the same thing as the old infrastructure days. And mostly developers tend to forget that. We just feel like, oh, awesome, Docker, you can just put anything in there and it runs. We downloaded it from the internet or get it from Docker Hub and run it. There were critical network exploitable vulnerabilities in that containers. Ooh, forgot about that. And the same thing could happen over here. So we did the scanner on a container in a later version of the Claire scanner with a more updated database, as you can see in the date of when the vulnerability was found. And you can see that we found some vulnerability. That vulnerability actually came from a wget which was only used when creating the container. So it's not really a problem, but still the fact that it's there should alert you about, okay, so when we're creating stuff or when we're building it or when we're using it, we might actually run into trouble. And the problem is, Claire can only pick up those things that have registered vulnerabilities. So the moment you create your own beautiful jar files, your own Go programs, your own executables or whatever, Claire won't find anything. So think about the applications you create yourself. You have to do something with that before you start using those within Claire or within, sorry, any Docker container. All right, now the major question was obviously, given all that stuff that I just talked about, did it work? Actually, it did. We found a path traversal. We found some reflected cross-site scripting. We found a few container issues in various containers that were being used. And there were a bunch of false positives found by Zep that we could filter out with the pipeline. And that was only on a single application from the customer using multiple services. They had many more applications that we still needed to scan, of course, but at least it worked. And not all components were in, but at least we had a lot of value there. Well, obviously, why would I need a week to build this, right? What were the bumps on the road? So the first thing is, of course, if you think everything is automated, you'll get a lot of noise. False positives is really a problem because the more applications you have, the more scanning will be applied, and the more especially dynamic analysis tooling will find false positives and start reporting those. So you have to suppress that. And how do you do that? So we first figured, okay, many of these applications actually have some tooling to mark something internally as a false positive. But that would mean that for every single application, you have to do the same thing. And you have to reconfigure the application over and over again. And if the application loses state, we're done. The other one was, of course, to use a database or a table that's provided by a framework, such as BDD security. We've used using that, by the way. Awesome. It will be lovely next time if I see more hands, because I think the framework has a bunch of nice tools. And if you want to start somewhere, this is great. The only problem with this is if you have multiple applications that shift, because there were many deployments over 2 weeks, with different services being deployed, this doesn't scale well. So we ended up that you had to use either Fitfix or Defect Dojo or another API where you, with a bunch of users, could actually manage all the findings that were in there and could easily manage the data. Another problem was legacy APIs. So as I already told, right, that the Amazon Web Service hosted application will be an interface to the legacy APIs. So what would happen is when you would start spidering and start scanning and put requests to Nginx, they will be handed to the Scala application, and then the Scala-based application would forward stuff to the actual backends and break it. Before we could start up the warehouse again, it would take a very long time because manual pen tests luckily already showed this, but you don't want to automatically break your legacy systems. So you have to do something about that, which was a bit painful. Luckily, the team already did quite a lot there, at least the application development team responsible for this application. So what they did is when you would do the request, you would actually end up with a stub. So the API definition would then be used to generate automatic stubs. Swagger has support for that. And with that, you can basically make sure that you would never reach the actual legacy APIs. The only problem is, of course, you still have to test that manually afterwards. And, well, you're not redeploying a mainframe every time, at least they weren't. That stuff was ancient, so that was cool. And we could be made sure that stuff that was continuously redeployed to test the Scala APIs were, properly tested every time. The next thing that we were running into, of course, was talking to the teams. You never want to frustrate a developer because what you often see, and I'm going to repeat that again, I'm sorry about that, but I think it's necessary, is you don't want to frustrate them. And the most important thing is if he finds out that there's a bug in his system or a vulnerability that's already there for ages, the first thing that comes to some of their minds is, oh, it's already there for such a long time. Sure. I got a deadline, remember? I don't know, should I fix it right now? Or the other way around, that's important. But which components were responsible for that again? That's 3 months ago, who coded that? What's the idea? That takes time. You don't want that. You want to make sure you can help the developers by giving them feedback fast. What you often see, for instance, if you do your yearly pen test, the pen test by itself might not be very effective in scope and depth. Ergo, start automating. The other thing is a developer has a hard time remembering what he created in January if you're testing it in December. And that's because they have to create a lot nowadays. So automate all the things, because I can't give feedback manually that fast, but I can do it if I automate it. And be part of the team. Make sure that once you create your tools, you start scanning, you're walking alongside the teams. Be their coach, help them, work with them. It doesn't say anything about how to create a pipeline, I know, but being part of their team and helping them to do the things right is often more important than the whole security by itself. So if you still have a security team or you're only part of that security team and you only meet people to do a plenary review, you probably have something to do as a security specialist. I recommend move out, start talking to them more often, have a coffee with them at least. A filter and suppress false positives ASAP, because the more false positives they get in their pipeline or get from you manually, the more they feel like, does this guy even know what he's talking about? I'm sorry, man, but that finding is for Microsoft SQL Server, and this is a NoSQL database. What? You want to make sure that doesn't happen. So make sure you filter that ASAP and maintain that filter, because the filter might first be correct, right? But when they change the technology stack, some false positives might be false positives at all anymore at some point in time. And use known tooling. So everything you can use in for quality checks or whatever should be something that the developer easily understands. If it's built by security people and it feels good to security people and you offer it to your developer and he starts having this big question marks over his face, you probably chose the wrong tool, or you better manage it yourself and make sure that the developer still gets feedback from it. So yeah, we didn't integrate burp proxy. And that's first of all because we needed custom builds to have it properly containerized. Otherwise, we had weird runtime issues with the container, or the containers were highly privileged, which we didn't like. At the time of testing, there was hardly any additional extension necessary to have a proper REST API. So you couldn't do proper calls to the running burp proxy to do something. But SAP already has an API out of the box, which you can easily use. So that's why we ran off with that one. All right. One thing that's really important, I believe, is that security automation doesn't mean no manual pen testing, because giving feedback fast is important, but doing cyclic manual penetration tests of something is also important, because you will never find everything. Tools aren't built for that. I just explained with, that many of the static analysis tools wouldn't work properly on the code base, but dynamic tools might not find everything as well. It's because, for instance, Zap misses a lot of context. So a stored cross-site scripting attack, which is actually happening, might later on be detected as just plain script that is supposed to be part of that API call, whereas that was actually a stored cross-site scripting attack. So that's a problem. So you still need manual pen tests with a high iteration, that is. Please make sure you're not running for the yearlies. And if you are, try changing it. You could still follow the same process, because you don't want to make a pen test a very special procedure, because the moment you're doing that, the automated part really becomes distinct from the manual part, which makes it harder for developers to manage what what the expectations are and what they have to do. If they have a single source of truth in terms of their backlog, so I still assume Jira over here, but any other backlog will do, you can use the same flow. And for a security team, you can have the same registration. So make sure you don't have 60 different Excel files and PDFs lying around from different external pen test parties, but try to make sure you're using the same process, so it becomes unified and easier to scale. Because scaling is the most important thing when you start having multiple deployments over time. So the manual pen tester does his job, and for most of the stuff he finds, you either assist or take these results and put it in there in FlatFix or Defect Dojo or whatever, or you let the pen tester do it himself if he's really part of your company, because it's not that hard. It's just adding a bunch of blobs. All right. And it still actually holds no matter how many tools you're going to add, because tools are still tools. And this might sound contradictory, like, hey, he's just saying automate, but the tools don't. Well, if you're at least able to filter about 70% of all the issues that are there, then you already have a large impact, because that means that the pen tester can start focusing on stuff that's harder to detect, but still really matters. And he can actually use the results from your pipeline to start the discovery phase, to have an idea of what's going on over there. Because otherwise he has to do that as well, which means that he is losing a lot of time in his pen test to start understanding what might be out there. So that's really important, I believe. The next thing, which was something a bit sad to us, remember that I talked about that it was the end of December that we did pen test? So a bunch of people were away. And not only that, the platform got a bit unstable. So the weekend beforehand, we got a Slack from the platform team saying, we have platform stability issues. You can still continue if you want to, but you're kind of on your own. Luckily, they still helped us after office hours, having coffees and doing stuff, because they were really dedicated. But it's not a good idea in general. The time that we needed to implement this could be way shorter if you would have been really part of the platform team and together create this. That would have eased the pain and make it a lot easier to make it work. Another thing that we learned later on is, even though that you try to shorten your checks, combine checks in parallel, make sure that you only do short runs of tools during your application pipeline, it still becomes very lengthy, because the more app sprints, it's only just if you talk about Zap, the more stuff you deploy, the bigger your API becomes, the bigger the scanning becomes that you have to do, or the surface that you have to scan through and stuff like that, the harder it becomes, or the more time or computational intensive it becomes, which means that the developer has to wait longer. That doesn't work. Even if we're just talking about minutes, it's still frustrating for a developer, because we're used as developers to get feedback ASAP. Test is green or not, move along, deploy, run. And now all of a sudden, waiting for Zap? What? Okay, well that doesn't work. So you have to separate that out. You need a security pipeline next to your application pipeline. So the application pipeline is basically what a developer faces. Short, quick feedback all the time about, the simple stuff in life, like dependencies, If you have older languages, you could use some scalable SaaS solution that actually gives feedback fast, and you run along, and it really works. But the stuff that takes longer amount of time because there's many hosts, for instance, in the network that need to be scanned, there's a lot of things that are going on, make sure that's a separate pipeline. Again, automate, because if you do not automate that pipeline and you're going to do this manually because, A, we already automated half of it, you're going to run after the fact. Because the moment the new deployment is done, your prior pen test results might be invalidated. Or, yeah, at best case, it means that the stuff that you found earlier is fixed. At worst case, they deployed something that was far worse than before because new and stable structures, a lot of issues with that. So let's make sure that doesn't happen. Yes. It highly depends on the language because if you, and I think I have to go back for a few slides, if it's okay with everybody. So if you look at this slide, for instance, a lot of time is being consumed by the build, the unit, and the end-to-end test. So the additional time over here depends on the amount of APIs being tested and the width of the API. On average, if ZAP is already running and just extends its context, it's a few minutes. But if you make the awkward mistake, oh, that's actually a good thing, good lesson learned. If you try to spin up ZAP over here every time again and you try to get somewhere, it becomes way longer depending on your infrastructure capabilities and the resources allocated. But the overtime added over here is not that much. The other problem, of course, with Claire and other tools is that they're depending on databases and other systems that need to warm up. So you need to make sure that, as in that the vulnerabilities are downloaded to the databases before you start scanning. So if you take all of that away, you can do it in a few minutes. But otherwise, you either break here in half an hour, actually, because it takes that long before you downloaded all the different feeds. And over here, it might take a lot of time depending on the size of the infrastructure. And obviously, with the evolution of SAP, we learned that if you make sure your developers have proper Swagger API definitions created, you can teach SAP in a very easy way on, or very quickly, which endpoints are there, what the variables are, it should be able to fuzz, and it can move along. Now those minutes or the dependency of the end-to-end test actually is dropped, which means that you could actually parallelize that because, hey, you already got it deployed to develop, why not parallelize the scanning and the rest? Of course, there's much more you can do if it comes to Docker security. We just did this simple scan with Claire. It would be much better that when you create your Docker file, you check it with Docker Bench. When you create a container, use OpenSCAP or Anchor to validate it as well because it uses different feeds and has policies in there. If you think this is all new to me, what Docker security, but you are using Docker in your organization, just make notes or create a screenshot or check it out later on. Because one of the major issues that we have lately with our different customers is that there's a lot of vulnerabilities in those containers, or that the infrastructure isn't necessarily an upgrade in terms of security, depending on what we had in the old days. And if you have infrastructure, there's OpenVAS, again OpenSCAP. There's InSpec and lots of other tools. And during AppSec 2016, there were many beautiful presentations about those. And I'd say to you all, take those tools seriously. You can easily automate it. They have APIs, they have definitions. Use them, start running. And it's not hard to use it. It might look fancy, but they're so well documented that it's very easy to implement. Don't do this by hand, that's sad. Obviously, well, you know, for SSL, TLS, certificate inspection, all that jazz, there's tooling available as well. And every language has its own quality and security tooling already. Developers actually often know, especially the senior guys that are in the field for a very long time, already know about those quality tools. So if you're really part of their team, you'll know about it. And you can help those juniors to make sure that everything is set up. All right. Recap. Well, again, automate all the things. Get feedback fast. Containerize as much as you can because reuse and because scalability. Filter false positives, otherwise you're just creating noise. Stop legacy APIs if you have such older systems because you don't want to automatically break them. help developers, do not frustrate them at all costs. And you still need manual pen testing and reviewing. And get platform team support. Your platform team and your developer teams are your friends. Make sure you keep it that way, or otherwise become their friend. And every part of the pipeline you get done is a blessing. Even if it means you just only have the third-party dependency checker in there, you know, the OWASP dependency checker or retire for JavaScript or whatever, every tool that you start adding on top of that is a blessing because you can start automating. All right. Given all that, do you have any questions?
First, let me thank you, Jeroen.
Thanks.
After the questions.
Yes, good idea.
Any questions? Any questions? They're all tired.